So hello everyone and welcome to Physics Wallah. Guys, hope you all are doing well and your preparation is going to the up to the mark. I welcome you all in this beautiful course on signal and system, in which we are covering a very interesting and very important topics, that is characteristics of a signal, in which I think I have covered two topics. One is the energy and power, and other one is your periodicity. Okay, now in today's class we will cover the symmetry. But if my voice is clear to you, if everything is clear, then please let me know so that I can proceed further. Let me check from my end also. Hello, hello, hello. Yeah, I think voice is clear. Yes, so let's start now. What we covered in the last class, we have covered, that is, we have covered a power and energy signal. We have covered energy and power signals, and I have given you the lot of conclusion that a signal is a bounded in nature. Bounded means that its value is not going towards infinitive. Then the signal is, let's say, energy signal if it is having a finite area also. And if a signal is bounded and having an infinite duration, then we will say that signal is power signals. All the periodic signals are power signals, and vice versa is not true. And all the unbounded signals are neither energy nor power signals, that we have covered in the last class. Okay, fine. Now in today's class, what I want to cover is symmetry. On signal. So it is one of the most important topic, in which we will cover a lot of symmetry, that is the conjugate symmetry, conjugate, let's say even symmetry, conjugate, odd symmetry, skew symmetry, and all. Even symmetry, basically odd symmetry. This kind of symmetry we will cover, and we will solve a lot of problems on that if time permits. Let's start. So before we start, let me define the nature of a signal. See here, you know that this is my axis in time domain. Okay, so this is axis in time domain, and we generally plot the signal in this form. A general signal plotted between minus a to b, having this value to be c. Here we always say that this y-axis, okay, is, hello Pratiksha, this y-axis is in general real in nature. We always assume to be real, and this x-axis also is real in nature. See here, when I say the signal x of t, then whatever this is defined between minus a to b, okay, defined between minus a to b, what I want to say is that this t axis, this x axis, or this epsica is always, find it, this is always real. It is real in nature. It is always real in nature. But this y-axis is in general complex in nature. What I want to say is that it has a format, let's say alpha plus j beta. It has a format alpha plus j beta, in which I say that if, let's say, beta is equal to 0, then it is only alpha, which is C here. You may take it to be alpha, whatever. You may take this to be alpha, no problem. This to be alpha you can take, but in general it is a complex in nature. What is the meaning is that, see here, when I say that this is a complex in nature, this means that it may have a magnitude and it may have a phase also. And we can plot separately the magnitude with respect to t, and we can plot phase with respect to t. Good morning, good evening, 𝐁𝐚𝐿. So simply if I say, okay, simply if I say that this is nothing but a real axis, this is a real axis, complex number, so this should be having a magnitude as well as phase. So in general what I am saying is that if I say that I have x of t, then x of t can be written as x of rt plus j times of x of it, in the same form as this, in the same form as this. So x of rt plus j times of x of it. If signal is purely real, imaginary part is 0. If signal is imaginary, then its real part is equal to 0. Okay? And what I'm saying is that if xt is defined, then we can find out the complex conjugate also. The complex conjugate of the function can be written as x of rt minus j x of it, and from which, just take this as equation number 1, just take this as equation number 2, and we can find out the real part and imaginary part of the function. What is the real part? The real part is xt plus x conjugate of t divided by 2, and the imaginary part is xit is xt here. If you subtract this one, minus x conjugate of t and divided by 2j. Check it please. If you subtract both this equation from equation 1 and equation 2, then you will get this is a real part and this is the imaginary part. Let me box it first, because it is one of the most important observation that you have to always take care of. Okay, let's take an example. Suppose if I am saying that example, I am saying, let's suppose we have e to the power j10t. You know that it can be written as e to the power j theta is cos theta plus j sin theta, means it's cos of 10t plus j sin of 10t. You can write like this. Similarly, e to the power minus j10t is can be written as, the complex conjugate can be cos of 10t minus j sin of 10t in this form, and hence you can write cos 10t as what? E to the power j10t plus e to the power minus j10t divided by 2. Similarly, you can write sin 10t as e to the power j 10t minus e to the power minus j 10t divided by 2j. So it is e to the power j theta minus e to the power minus j theta divided by 2j. You will say like this. Okay, cos and sine. But for example, if signal is real, let me change the color. If signal is real, this means that x of it is equal to 0. The imaginary part is equal to 0. And in this case, we will say that, see here, xit is equal to 0. See here, both this equation. So what is the relationship? We will get that xt is equal to x conjugate of t. Very, very important. xt is equal to x conjugate of t. xt and x conjugate t both are same. But suppose if you are saying that if, let's say, call it as k, call it as b, if signal is imaginary, if signal is purely imaginary, then real part is 0, xrt is 0, and then xt is equal to minus of x conjugate of t. You will say from this, see, change the color, that is xt is equal to minus of x conjugate of. Very, very important. xt and x conjugate t are negative of each other. xt and x conjugate are negative. See, 𝐂𝐸𝐳𝑥𝑖𝑡, you can put xt in front of this. xrt is equal to 0. So this is one of the most important part of this function. So let's take an example for this also. Suppose if I am saying example, suppose I am saying that xt is j10t and xt is 5. Let us find out the imaginary part of this function. Let's find out the imaginary part of this function, though it is purely imaginary. But suppose someone asks you the imaginary part. The imaginary part is x of it is what? xt minus x conjugate of t divided by 2j. So what is xit then? It is j10t minus complex conjugate. Here complex conjugate of this one is minus of j10t divided by 2j. So this will gives you what? This will gives you what? It is j20t divided by 2j, and hence it is 10t. And look at that. If this signal can be written, then this can be written as xt as the real part is 0 plus j10t. So this is the imaginary part of this function. This I get from here. And its real part is equal to 0. You can find out the real part of this function is purely 0. See, what is the imaginary part of this function? Sorry, imaginary part of this function is, see here, 5 minus complex conjugate is same, 5 divided by 2j is equal to 0. So 5 plus j0 you can write. The imaginary part is completely 0. The real part is of this function is 5. Imaginary part of this function is 10t. Is it clear? So whatever written after j is a complete imaginary part of this function. And how will you plot this function in terms of t? See here, we can say that 10t, okay, 10t is having phase like this. This is what a 10t is. This is the magnitude mod xt versus t. And if you talk about the phase, this is having a phase of 90° for all t. So this is having the phase of, that is angle xt versus t. That is true only when the function is purely imaginary. And here for imaginary signal, the angle will be either plus j or minus j, that depends on the sign of this imaginary part. Plus 90° or minus 90°, that depends on the sign of this, nothing but my function. Okay, if it is clear, that's what the nature is. See, why I take this function, because I want to tell you one thing, very important thing, that the signal in general never be a real function. We always choose this representation to be real. See, this is a myth, please. That signal may be complex also. It has a complex conjugate, and it will be broken into its real part and imaginary part. That's the thing that you have to take care of. Okay, please, while dealing with a signal, don't always assume to be real, because this is the common mistake. We always think that xt is real. Real is defined, okay, whose imaginary part is equal to 0. Or signal is purely imaginary means it has a phase of plus 90 or minus 90 depending on the signal. Vice versa can also, we will say what, that if a phase is plus 90 minus 90, the signal nature would be imaginary in nature, either in magnitude, either in time domain or frequency domain, whatever. So by looking the phase plot itself, we can comment on the signal nature. If the phase is plus 90 minus 90, then simply we will say the signal nature would be imaginary in nature. Okay, so that's what the point is. Now, why we use it, why we say this, and where we use? We will use it in a very interesting part of this one, which is nothing but my symmetry on signal. Okay, let's talk about. First of all, what do you mean by symmetry? Let's see here. Consider a signal like this. Let's imagine that I have a signal. In general, signal is complex. Let me call this as xt. So here, what do you mean by symmetry? First of all, understand this definition: minus a comma b, where this is real, and let's assume to be c, height. Here, symmetry means what is the behavior of a signal with respect to both these axes, x-axis and y-axis. That's what the meaning of symmetry is. When I say the word symmetry, then the meaning is very simple. That what is the behavior? What is that is signal behavior with respect to x and y-axis. As I say earlier, that in general, signal is complex conjugate. Signal is complex in nature. This means that x of t, I am taking x of t, I am first taking the conjugate. I am first taking the complex conjugate of the function, and what I am doing is that I am taking a reversal on it, x conjugate of minus t. As I told you, the signal is a complex in nature, so start with xt, take the complex conjugate, and I have x conjugate of minus t. Now, let's start the point. First point, a. If xt is equal to x conjugate of minus t, if both are same, if xt is x conjugate of minus t, then signal is said to be conjugate symmetric. Conjugate symmetric. Signal is said to be a conjugate symmetric. We will take this by example, don't worry. But let's take B part also. B said that if, on the other hand, xt is equal to minus of x conjugate of minus t, minus of x conjugate of minus t, then we will say that is a conjugate anti-symmetric. Sometimes we say that it is a conjugate skew symmetric, same meaning. Conjugate symmetric or conjugate even symmetric, conjugates anti-symmetric or conjugate skew symmetric, conjugate odd symmetric, all are having the same meaning. Let's take an example. Example. Suppose xt is j10t, xt is e to the power j10t, and xt is j e to the power j10t. Suppose three signals I have, and I have to tell, this is B, this is C, I have to tell that whether these signals are conjugate symmetric, conjugate skew symmetric, or conjugate anti-symmetric. Let's do it. Let's do it. Let's do it. First of all, we know that xt is defined. Let's take x a conjugate of minus t, x a conjugate of t first. It is minus j10t. X a conjugate of minus t I have to know. See, how will you get x conjugate of minus t? Simply wherever you have a t, replace t by minus t. This means that this should be minus j10 of minus t, and hence it is j10t. Now what is the relationship? X conjugate of minus t. Are they same or they are different? Let's do it. See here. If you see, then they are same. xt is x conjugate of minus t. xt is x conjugate of minus t. Simple, very simple. And hence signal is conjugate symmetric or conjugate even symmetric. Meaning is same. Why we are saying even symmetric, I will tell you in a moment. Similarly, let's talk about this one. First, define xt, x conjugate of t is j e to power minus, is e to power minus j10t. And again, if you take x conjugate of minus t, replace t by minus t, minus it is e to power j10t. Again, t is replaced by minus t, minus become plus, and hence again xt is equal to x conjugate of minus t. Similarly here, again it is CES or CS, same. It is x conjugate t, we will say it is what? Minus j e to power minus j10t, x conjugate of minus t is what? It is minus j e to power j10t again, which is minus of xt. So what we will get? We will get x conjugate of minus t is equal to minus of xt. This means that the signal is conjugate skew symmetry or conjugate anti-symmetry or conjugate odd symmetry. Meaning is exactly same. This is how we check the signal is a conjugate symmetric or conjugate skew symmetric. But let us assume if signal is real, if signal is real, means xt is equal to x conjugate of t. xt is equal to x conjugate of t. And in this case what we will have, see here, suppose let's talk about A. Suppose we have xt is equal to x conjugate of minus t. What? Conjugate symmetric. This becomes xt is equal to x minus t for real. And this is very popular symmetry. You know that this symmetry is very popular symmetry. This we call it to be a even symmetry. This we call it to be even symmetry. Xt is equal to x minus t, then we will call this as a even symmetry. Similarly, let's talk about B. If we have xt is equal to minus of x conjugate of minus t, that is, we talk about conjugate skew symmetric, then for real xt becomes conjugate remove minus of x of minus t for real, and this is very famous symmetry which we call it to be odd symmetry. This we call it to be odd symmetry. You understand my point? For real one, conjugate skew symmetry will convert it into what? Odd symmetry, and conjugate symmetry will convert it into even symmetry. So let me write this. So we have what I want to say is that, see here, we have conjugate symmetry. It converted into even symmetry. Sorry. If this is real. Similarly, we have conjugate skew symmetry and we have odd symmetry. So this will again convert it into, if it is real. So what it is? It is xt is equal to x conjugate of minus t. What it is? Xt is equal to x conjugate of minus t minus of x conjugate of minus t. It is xt is equal to minus of x minus t. It is xt is equal to x of minus t. See, reverse is also, they means that conjugate is removed for real one. For real one, conjugate is removed. See, why reverse is also true. This means that if signal becomes complex, then this odd symmetry will not go to here. Odd symmetry will go to here. So this is true when this is complex. Same is here. This is true when it is complex. Okay. So very, very important relationship we have derived, that conjugate symmetry we have will convert into even symmetry. and even symmetry will convert into conjugate symmetry if signal is real and complex. That depends. Let's draw some conclusion on even and odd symmetry. See here. Let's take, for example, if we have a signal. Suppose we have this. Let us consider even symmetry. For even symmetry, listen carefully. Since xt is 𝐿 minus t, this means that signal is mirror image with respect to y-axis. What is the meaning? If signal is purely even in nature, this means that whatever you have on the here, it should be present in the second quadrant, first and second quadrant also. Then only they will overlap. So let's take two examples based on this. Suppose I have this kind of signal. This is purely, see here, let's say consider it to 0, this is 2, this is minus 2, it is 2 and it is 2. If you consider this as a xt, this is a xt, then if you fix this and if you take the mirror image with respect to this, then it will definitely overlap. Okay, and hence it is mirror image with respect to y-axis. You may take it to be a cos function also. See, you may extend this to cos function also. What is the cos function? See, exactly in the same fashion. Okay, and if you consider this to be a t, then cos t is equal to cos of minus t. Same. That's what the meaning of a even function. So you will take a mirror image with respect to y-axis. So the width and height must be same. Then only you will take a mirror image. Width both the quadrant and height in both the quadrant same. I am not writing this. I am just writing that mirror image with respect to y-axis. You will take, then you will get the same signal. But for an odd, let's consider this. For an odd, xt is equal to minus of x of minus t. Listen carefully. Now here, see, this is reflection. This is, sorry, reversal. What is the meaning of reversal? Mirror image with respect to y-axis. And what is this? This is reflection. What is this? Mirror image with respect to x-axis. First, understand quickly what do you mean by reflection. See here. Suppose if we have this signal minus a, b, c This is xt. Then what is minus xt? Minus xt is, it is a minus a comma b, but this one, you just take the mirror image with respect to x-axis. That's what the meaning. Now look at that. See, xt is equal to minus of x of minus t means that we have both axes involved. Y-axis also we have to take mirror image. We have to take mirror image with respect to x-axis also. This means that we have to take the mirror image with respect to x and y-axis. This means that both axes are involved. So symmetry must be common point between them. What is the common point between x and y-axis? Origin. So what I am saying is that symmetry is with respect to origin. Now, symmetry is with respect to origin. This means that hence x of t at t is equal to 0 must be equal to 0 for odd function. Very, very important observation. What I told you. See here, since symmetry is with respect to origin, hence x of t at t is equal to 0 must be equal to 0. What is the meaning? See here, let's consider example. Let's take an example A. If you consider sine t, you know that sine of minus t is equal to minus of sine t. Means x minus t is minus of xt. Simple. So look at the curve of sine t. You look at the curve of sine t, then don't you think that sine t looks like this one? See? See here? So what I am saying is that look at this point. Look at this point. See here? At origin, the value must be 0. At origin, the value must be 0. So that's why, see, if you consider it to over one period only, let us consider one period. What is the meaning of this one? See here. If you, let's say, flip around y-axis, x-axis, and then flip around x-axis, then it will exactly overlap. What I am saying is that if you flip around here, you will get, and if you flip around here, then it will exactly overlap. That's what the meaning of symmetry with respect to origin. Okay, that's what the meaning of symmetry with respect to origin. I'm not writing this. Same is tan t. Same is tan t. If you look at the plot of tan t, then you will get the same thing. Exactly one plot I want to tell you more. Let's talk about this one. See? Let's talk about this one. If this is 0, this is 2, this is minus 2, this is also 2, and this is minus 2. This is xt. Question is that, see here, will you consider it to be odd? One thing is clear, that at 0, the value is 0. Now what I am doing is that I am just flipping. Fix this, fixing this part, and if you take the mirror image of this function with respect to this, then you will get this one. See, this is what the mirror image of the function is. And when you take the mirror image with respect to y-axis, then you will get, see here, you will get exactly overlap here. It will exactly overlap. So first you take the mirror image of this function with respect to this, and then take the mirror image of this function with respect to this, then it will exactly overlap. That's what the meaning of odd signal, and hence all the odd are nothing but my at 0. So this is the example number 1, example number B, example number C. Example number D is, you will take a t cube, t to the power 5, t to the power 7, they all are odd. Just go in a Google, just plot, write this function in Google, and you see the plot that they are just a 0 at nothing but my 0. But it doesn't mean that 0 at 0 will gives you odd always. See, 0 at 0 is there, but is it odd? Vice versa is not true-minded. My dear, you have to take care this. 0 at 0, it is, will not give you odd. This function is completely 0 and 0. But is it odd? No, it's not odd. You understand my point or not? It is not the odd function, minded. Okay? You have to take care of that xt is equal to minus of x minus t has to be satisfied. So only, this is not the sufficient condition, though necessary condition. Though it is a necessary condition, but this is not the sufficient condition, minded. You understand my point or not? Okay, so this is what a meaning of this function. Okay, but let's talk about one more example. Signum t example. Signum t. How signum t look like? I told you many times about signum t. Here, this is what my signum t is. So it is minus 1 and it is 1. By looking this function, if I fix this and if I flip this, here with respect to x-axis, and if I flip with respect to y-axis also, then it will exactly overlap, minded. It will exactly overlap here. Yes, this means that it is looking like a odd function. Yes, it is an odd function, but question is that, is this condition satisfied that at 0 it has to be 0? Remember the definition of signum t. What is the signum t? What is signum t? Signum t is, see here, 1 for t greater than 0, minus 1 for t less than 0, and what is at t is equal to 0? We have to take the average. 1 minus 1 divided by 2. So it is 1 minus 1 divided by 2. It should be 0 at t is equal to 0. Has to be there. So this value, what I am saying is that this value, okay, this value mandatory has to be 0. This is t is equal to 0 is 0. T is equal to 0 is 0. That's what the meaning. You understand my point or not? So this is what my function, this is what my function is when we talk about the signum function. When we talk about the signum function particularly. Let's take one. Let's talk about this function. Consider this function. Suppose we have a function which is 2 to 4 and it is 2. Question is that here, can you tell me that the function is even or not? Check. check, let me write here, check symmetry on xt. Is it even? If it is even, there should be one portion here on which you overlap and it will exactly overlap, mind it. And if it is odd, then there should be a function which is, if you flip it with respect to y-axis and with respect to x-axis, then it should be overlap. Means what I am saying is that there should be a function which looks like this for odd, and there should be a function which looks like this for an even. But both are not present. This means that this is not an even or odd function. This is neither even nor odd. But listen carefully. Any function which is neither even nor odd, can be written in terms of even and odd function. Means what I'm saying is that x of t can be written as x of et plus x of ot. With the fact that if it is x of et, then it must follow x of e of minus t. And if it is ot, x of ot, then it is minus of x of o of minus t. To be there. Then what I'm doing is that taking reversal both the sides. Taking reversal both sides. What you will write? You will write this as x minus t is equal to x e of minus t, taking reversal both the sides, plus x o of minus t. But can I use this? See, x e of minus t is x of et. So this can be written as x minus t equal to x et, because they are same. And this can be written as x o of minus t is minus of x of ot. So this can be written as minus of x of o of t. Let me call this as the equation number 1. Let me call this as the equation number 2. That is adding 1 and 2 and subtracting 1 and 2. Here, if you add 1 and 2, then what you will get? You will get what? Xt plus x of minus t is twice of x of et, which will gives you x et as xt plus x of minus t divided by 2. One thing, by adding 1 and 2. And if you subtract both this function, then what you will get? You will get xt minus x of minus t is twice of x of ot, and this gives me x of ot equal to xt minus x minus t divided by 2. Yes or no? So this is what we called it as even function, even part of a function, and this is called it as This we call it as even part of xt, and this we call it as odd part of xt. This we call it as even part of x of t, and this we call it the odd part of x of t. So what I want to say is that though this signal is neither even nor odd, but we can find if not find 𝐿𝐸𝑡 and 𝑋𝐷. So how will you find? Let's find it. See here. So this is xt. This should be x minus t. This should be 𝐿𝐸𝑡. And this should be 𝑋𝐷. Let's find out. So what was my xt? Xt was this. So it is 2 to 4. It should be 2. That's what my xt is. Can you tell me x minus t? Yes, x minus t can be reversed version of this function. So it should be a reversed version of this function. So it is minus 4 to minus 2, it is 2. This is x minus t. Now tell me how you will get 𝐿𝐸𝑡. What is 𝐿𝐸𝑡? See here. 𝐿𝐸𝑡 is, see, xt plus x minus t divided by 2. xt plus x minus t divided by 2. So this means that, listen, if you add both this function, don't you think that I will get this function and this function? It is from adding, means what I am saying is 𝑋𝐸𝑡, which is xt plus x minus t divided by 2. It is 2 to 4. It is 2. It is minus 4 minus 2 to 2. But hold on, mind it that you have to divide by 2 also. So divide by 2 also. Divide by. This is what my 𝑋𝐸𝑡 is. Yes or no? This is what my 𝑋𝐸𝑡 of the function is. Similarly, if we want to find out 𝑋𝐷, how you will find? You have to subtract it. What is 𝑋𝐷, by the way? 𝑋𝐷 is xt minus x minus t divided by 2. So you have to subtract this one from this one. How will you subtract? See, this is the second quadrant. Second quadrant completely 0. 0 minus 2 is minus 2. This is first quadrant. 2 minus 0 is 2. Means I will get, you think that I will get here, forgive my drawing, this should be like this. Is it visible? Not visible. This one. Okay, so this should be what? 2 to 4. It should be again 2 by 2, and it is minus 4 minus 2, again 2 by 2. So that is the XOT of a function. So this we will say that XT and XET and XOT we can find out. I'm giving you the homework. Find even and odd part of I know it is a odd. Prove that the even part of this function becomes a 0. Prove that the even part of this function is 0. So it is 0, 2, minus 2, 2, minus 2. Prove that the even part of this function is 0. Prove this, that x of et will comes out to be 0. X of ot is same as xt. So odd part is same as x of t. This is x of t. So what do we say? We say that xt can be written as xet plus xot, and this can be written as xet as xt plus x minus t and divided by 2. Similarly, xot is equal to xt minus x minus t divided by 2. Now that is for real. Can we use this? Can we use this representation? Which one? This one. That is, if it is an even signal, and if signal becomes a complex, it becomes a conjugate symmetric. So how you will get conjugate symmetric? Simply put a complex conjugate on x of minus t. Similarly here, if signal is the odd symmetric, and if it is a complex conjugate, then simply put a complex conjugate here at x minus t. So what I want to say is that okay, we will find out the if xt is complex, if xt is complex, then we can find out the x conjugate symmetric part of t. How we will find out? Same from even part. Conjugate symmetric part we will get from even part by simply putting complex conjugate here. What? xt plus x conjugate of minus t and divided by 2. Similarly, we will get conjugate skew symmetric part. xcss of t. Wow. xt minus x conjugate of minus t divided by, because conjugate symmetric part we will get from odd part and conjugate skew symmetric part we will get from here. That is, I want to say that here I will get from this, and I will get if signal is complex. From here to here. That is, sorry, signal is real. arrow direction is different now. If it is real, it becomes this. If it is real, it becomes this. That's what the meaning here. So we have now 4 very important formula. Same thing is valid for discrete time. Just replace same thing. Let me write this. Same discussion is valid for DTS, T replaced by. So for DTS exclusively, I am not taking this. Just whatever I have discussed for CTS is equal valid for DTS. Okay. Yes. Fine. Let's take an example. Suppose I have xn as equal to 2 plus j3, j3, 3 plus j4, 6, and here is the arrow. Let yn is CAS of xn. Question is that find energy on of xn. Find energy of xn. Do it. I'm giving you 2 minutes. Do it fast. Let me take it as a numerical answer type. See here? Let's do it. xn is this one, 2 plus j3, j3 3 plus j4, and 6. Here is the arrow. Let's find out first x conjugate of n. It is 2 plus j3 minus j3 minus j3, 3 minus j4, and 6. We know that CAS of xn can be xn minus x conjugate of minus n divided by 2. So what is x conjugate of minus n? Minus n. Since here is the arrow, so if you take minus n, then just you have to write from the back, or you take the mirror image of this function. So it is how much? It is, see here, 6, 3 minus j4, it is j3 minus j3, and here 2 minus j3. So sequence by sequence we have to subtract this. Sequence by sequence we have to subtract this. So it is n is equal to 0. It is n is equal to 1. Sorry, n is equal to minus. It is n is equal to minus 1, n is equal to 0, n is equal to 1, n is equal to 2. It is what? N is equal to 0, it is n is equal to 1, it is n is equal to minus 1, it is n is equal to 2, minus 2. See, at minus 2 this is 0. At minus 2 this is 0. What is the sequence? CAS of xn a. See here, don't forget the 2. See, 0, because not present, 0 minus 6 divided by 2, the minus 6 divided by 2. At n is equal to minus 1, this is 2 plus j3. 2 plus j3 minus 3 plus j4. You will say like this. It's a minus 1 plus j7 and divided by 2. So it is minus 1 plus j7 divided by 2 at n is equal to minus 1. Okay, remove. At n is equal to 0, this is j3, this is minus j3. So subtract j3 minus j3. What? 2j3 divided by 2. 2 to cancel j3. Then here is the arrow. At n is equal to 1. N is equal to 1. 3 plus j4 minus 2 minus j3. What it is? 3 plus j4 minus 2 plus j3. 1 plus j5 divided by 2. Check it, please. Minus 2 j4, no, j7, no? Yes. 1 plus j7 divided by 2. And this should be 6. At n is equal to 2. 6 minus 0. N is equal to 2. Sequence is not there. So 6 minus 0 divided by 2. So it is 6. How will you know that my answer is correct or not? See here. Don't you think that this and this sequence are, see here, if you consider minus common, 1 minus j7 by 2 and it is 1 plus j7 by 2. What is the relationship between them? See, it is a complex conjugate of both and also minus of both. So if it is a complex function, then it's the x conjugate of minus n is there. It is x1 is equal to x conjugate of what? Minus of x conjugate of x minus 1. Check it. Minus of x conjugate of minus 1. And this is the definition of conjugate antisymmetry I have just covered. Look at this one. See, it is a purely real. Purely real. So, real function, this means the imaginary part is equal to 0, but they are negative of each other. Look, 6 by 2 and it is what? The second is x2 is minus of x minus 2. x2, this is minus 1, na? This is 1, this is 2, this is minus 2. So x2 is minus of x of minus 2. This means that my question is perfectly correct. What I get first, I get the sequence back xn x, let me call this as yn as, let me define this as a -3 minus of 1 plus j7 divided by 2 j3, 1 plus j7 divided by 2 is 3. You want to find out the energy of this function. How will you find? The energy yn is EY is summation n is equal to minus infinity to infinity yn into y conjugate of n. So let us define the y conjugate of n first. Y conjugate of n will be, this is -3, this is minus of 1 minus j7 divided by 2, this should be minus j3, and this should be 1 minus j7 by 2, and this should be 3. There is the arrow. Now what you have to do, point by point again you have to multiply. When you multiply both this function, don't you think that, see here, 1 by 4 is common, minus 1 by 2 minus 1 by 2 becomes 1 by 4, 1 plus j7 into 1 minus j7 is 1 square plus 7 square. It is 49, I think so. 49. Oh, sorry, 49 plus 1, 50. 50. And don't forget that minus 1 by 2, 50 by 4. So this sequence, let me change other. From here to here, the multiplication result is 50 by 4. Check it. From here to here, the multiplication result is 9. From here to here, what is the multiplication result? See, j square minus minus become plus, it should be 9. From here to here, again it is 50 by 4. From here to here, it is 9. So the sequence that I will get y conjugate of yn into y conjugate of n is 9, 50 by 4, comma, what? 50 by 4, 9, 50 by 4, and 9. Here's the arrow. I get yn into y conjugate of n. I get yn into y conjugate of n. Look. And don't you think that is a perfectly even symmetric? See, with respect to 9, they are perfectly overlapping with each other. It has happened. 100% has to be happen. Conjugate anti-symmetric is there, and when you multiply its function with itself, you will get the same result. Complex conjugate, you will get the real function always. Real and even. Now energy is you will add all this function. So it is 9 plus 50 by 4 plus 9 plus 50 by 4 plus 9. It is, I think, 27 plus 100 by 4. So it is 4 7 ja 28, 4 2 ja 8, 10, 108 plus 100 divided by 4, and hence it is a 208 divided by 4, and hence energy is, I think so, the 4 5s are 20, 52 joule. Check it. If I made a calculation error somewhere, please forgive me guys, because calculation is not in my hand, because I am solving just, I don't have any calculator or whatever, I just solving in front of you, okay? But the concept is clear. Concept is purely true. Concept is purely true. Okay? So that is what my symmetry. We talk about the real symmetry, even symmetry. So what we did is, see here, what we did is, we talk about symmetry in detail, in which we talk about first real signals, then we talk about imaginary signals, then we talk about complex signals, then we talk about conjugate symmetric signals, conjugate skew symmetric signals, we talk about even signals, and we will talk about odd signals. And then we talk about the real part, we talk about the imaginary part, we talk about the even part, we talk about the odd part, we talk about the conjugate symmetric part, and we talk about the conjugate skew symmetric part or antisymmetric part. Let us write quickly so that it will be revised 2 minutes. Real xt is x conjugate of t. Imaginary xt is minus of x conjugate of t. Complex, it is in the form of xrt plus jxit. Conjugate symmetric, xt is x conjugate of minus t. Conjugate skew symmetric, xt is minus of x conjugate of minus t. Even symmetric, xt is equal to x minus t. Odd is xt is equal to minus of x of minus t. What is the real part of xt? xt plus x conjugate of t divided by 2. Imaginary part of xt, xt minus x conjugate of t divided by 2j. xt plus even part, x minus t divided by 2. What is the odd part? xt plus xt minus x minus t divided by 2. Conjugate symmetric part, xt plus x conjugate of minus t divided by 2. Conjugate skew symmetric part, xt minus x conjugate of minus t. So we have covered that much of nothing but a complete thing. So let me number it also. 1, 2, 3, 4, 5, 6, 7 here, 8, 9, 10, 11, 12. So in total 13 general concept I have given you and a lot of problems I have given. Now with this, I officially declare that basics of signal is covered. From next class onwards, if we meet, when we meet I don't know, but if we meet then we will start is the basics of systems. This is the 12th lecture I have totally devoted on nothing but my completely signals. Okay, basics of signals and all. Now next lectures will be on basics of systems, and then we combine all these and we start the LTI systems and all. So fundamental part 1 is covered, right? Fundamental part 1 is covered. Fundamental part 2 will come soon. Okay, fundamental part 2 will come soon. So with this, thank you very much guys. Thank you. If you have any doubt, do post the doubt in comment box. I always watch your comment box and I try to give you answer. Those who have not joined my Telegram channels, go and find my Telegram channel, Pankaj Singh PW. Easily you will find my Telegram channels, and there you can post your doubt also. With this, thank you very much. Thank you.